Yeah, good morning. Yeah, this is H. Kelly. I'm from Korea Advanced Institute of Science, Technology, KAIST. I'm going to talk about the characterization of calcium sulfoaluminate cement exposed to accelerated weathering carbonation conditions. So here are the contents of this presentation. I'll go over with introduction factors affecting carbonation behavior of CS cement and CS cement exposed to an accelerated carbonation condition, role of magnesium oxide. Under the global crisis of CO2, the reduction of net CO2 emission is inevitable in cement industry, mainly due to the cement industry is responsible for about 5 to 8% of worldwide man-made CO2 emissions. There are several candidates for alternative cement binders. Among these, I have focused on CSA cement. As you may know, the typical properties of CS cement includes rapid strength development, shrinkage compensation, and low CO2 emissions. Meanwhile, the weathering carbonation is an inevitable phenomenon to cementitious materials and slowly affecting the durability of cementitious materials. Especially in Portland cement, the CO2 reacts whether it's a portlandite or with CSH, leading to the reduction of pH level, all of which can degrade durability. So I'm going to go through the early works on carbonation behavior of CS cement. So water to cement ratio is used for CS cement is an important factor affecting the carbonation behavior of CS cement. And low water content was found to decrease the carbonation depth, which signifies higher carbonation resistance. And Hodges et al. Reported increasing M value, which is the calcium sulfate over ilmenite, can increase the carbonation resistance. And then most hydrates of CS cement were converted into calcium carbonate upon carbonation. And the carbonation behavior of SCM supplemented CS cement was investigated by thermodynamic modeling, and replacement with SCM lowered the carbonation resistance, leading to the decrease in pH and eventually volumetric instability of the matrix. So this experimental research mainly focused on providing the detailed information about the CS carbonation behavior of CS cement and the role played by magnesium oxide upon carbonation. So CSA's clinker and gypsum were used to compose the CS cement, and then magnesium oxide was added to the sample at 0, 5, 10, and 20%. And these samples were denoted by M0, M5, M10, M20, respectively. And these samples were sealed carbonated for 56 days, and then carbonated for 28 days at 3% CO2 concentration. So these are XRD results of uncarbonated and carbonated samples. As you can see, the magnesium oxide incorporation preferred the formation of a monosulfate over ettringite. And upon carbonation, the ettringite and monosulfate still exist after carbonation in the samples with magnesium oxide. On the figure on the right, you can see a reduction in calcite peak signifies a decrease in the degree of carbonation. These are TG and XRD result of uncarbonated and carbonated samples. As you can see, the formation of hydrocarbonate over there became clear in the samples with magnesium oxide after carbonation. And we calculated the amount of calcium carbonate, and this was reduced by magnesium oxide incorporation. We did calculate it by integrating the derivative rate of each and every, and we found this number. Yeah, this slide shows the air NMR spectra of uncarbonated carbonate samples, and the air NMR spectra found upon carbonation, AFM, D, and LDH strongly persist in the sample with the magnesium oxide. And as you can see, with magnesium oxide, which is blue line, the tetrahedral air region was not altered after carbonation. So these are SEM sample, SEM images, and these are tonally plot of aluminum, magnesium, and silicon stoichiometry based upon EDS analysis. And from this SEM image, you can see the samples with the magnesium oxide mainly consist of monosulfate and the CaSH after carbonation. And based upon EDS analysis, you can see magnesium oxide mainly triggered formation of hydrocarbonate and the magnesium-rich reaction product with high silicon ratios. This is the final slide of my talk. These are the carbonate depth result based upon the phenolphthalein indicator test. And carbonate depth result shows the incorporation of magnesium oxide increase the carbonation front, and as we expected, the hydrocarbonate which was formed by magnesium oxide incorporation captures CO2, leading to an enhancement in the carbonation resistance. So these remarks conclude my presentation. So as I said, the weathering carbonation is an inevitable deterioration phenomenon of cementitious materials, so which should be seriously taken into. Also, a lower water-cement ratio and higher M value of CS cement may enhance carbonation resistance. And carbonation CS cement induce the full carbonation of ettringite and monosulfate. And incorporation of magnesium oxide in CS cement led to the formation of mainly hydrocarbonate over ettringite, thereby mitigating the CO2 ingress. Finally, the presence of hydrocarbonate in the magnesium oxide modified CS cement can improve the carbonation resistance. References. So we fully appreciate the support by National Foundation of South Korea. Thank you for your attention.